Hello friends, welcome you all in the course of Basic Electrical Engineering. In that we are already started the unit number 1, that is DC circuits. These are the unit contents. As discussed in the last lecture, series circuit. In this lecture we are going to discuss the parallel circuit. That is, we will get the derivation of total resistance of the parallel circuit. We already know the derivation, that is formula 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3, where R is the total resistance of the circuit and R1, R2, R3 are connected in parallel to the circuit. First, we will see the definition of the circuit. A parallel circuit is the one in which the circuit elements are connected in such that the either ends of the components are connected together and a single terminal is formed. Means, and same is the workout for the second terminal, and thus the two ends are formed and these two ends are connected to the power supply. We will get the parallel circuits. Here we are see either ends of the components are connected together and a single terminal is formed. Means here we consider three resistances. Here we are see the figure R1, R2, R3 are connected in parallel. A and B are the two end points and these two end points are connected to the power supply or voltage source. Parallel circuit means either ends means R1 having two ends, one is starting, second one is ending. R2 having and R3 having similarly 2 points, starting point and ending points. Either points are connected means starting point of the R1, starting point of the R2 and starting point of the R3 are connected to form a single terminal means A terminal. And same is the workout for second terminal means R2, R3 and R3 having the three ending points. These three points connected together to form the terminal B. And these two terminals are connected to the power supply. Our circuit becomes parallel circuit. When voltage V is applied to the circuit, at that time current I is flowing through the circuit. Here I1 is the current flowing through the resistance R1, I2 is the current flowing through the resistance R2 and I3 is the current flowing through the resistance R3. At point B, again the current I will be flow in the circuit and V is the applied between voltage to the circuit. Here, in the above series circuit, when voltage V is applied to the point A and B, due to which current is drawn from the battery, as discussed in the last slide. R is the equivalent resistance of the circuit. R means equivalent resistance or total resistance of the circuit. Let I1, I2, I3 be the currents flowing through the resistances R1, R2 and R3 respectively. By using Ohm's law, we can write V is equal to I into R. Okay, where V is the total voltage of the circuit, I is the total current of the circuit and R is the total resistance of the circuit. You have to find R of this circuit. Also, we are applying Ohm's law at each element. That is, we will get the another equation V is equal to I1 into R1 when we apply Ohm's law at resistance R1. V is equal to I2 into R2 when we apply Ohm's law at resistance R2. And at R3 we will get the equation V is equal to I3 into R3. Okay. Next we apply KCL at point A. That is, at point A, current is divided into three parts, I1, I2 and I3. We already studied the Kirchhoff's current law. Incoming current is equal to outgoing current. Summation of incoming current is equal to summation of outgoing current. That is, I is equal to I1 plus I2 plus I3. Put the value of I1, I2, I3 as discussed in the last slide. I is equal to V by R, I1 is equal to V by R1, I2 is equal to V by R2 and I3 is equal to V by R3. Just rearranging the equation, we will get the value of I1, I2 and I3. Here we take V as a common and it will be cancelled. We will get the final equation of the total resistance of the parallel circuit, that is 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is the final derivation or equation of total resistance calculation of series circuit. Okay. Next we will see the conclusion of the parallel circuit. Thus, in parallel circuit, the reciprocal of the equivalent resistance is equal to the summation of the reciprocal of the individual resistances. Also, in parallel circuit, the voltage applied across each circuit element is same or equal to the applied voltage. Means we can apply voltage is V. This voltage is available in all resistances. That is, voltage across R1 is also V, voltage across R2 is also V, and voltage across R3 is also V, because R1, R2, R3 are connected in parallel. That is, in parallel circuit, voltage is same and current flowing through each resistances will be different. Okay, this is the total derivation of the parallel circuit. In next lecture, we will see the conversion of delta resistances into star resistances or delta to star conversion. If you find this information is useful, please do share with your friends and don't forget to subscribe our channel for next videos or next notification. Thank you.